everyone, my name is Holly Miller and I chose to do the flyweight pattern. So for the intro, it is a structural pattern whose intent is to use sharing to support large numbers of fine-grained objects efficiently. A flyweight is a shared object that can be used in multiple contexts simultaneously, so it acts as an independent object for each context. We'll be using two key concepts throughout this presentation. Intrinsic state, which is stored in the flyweight, and it consists of information that's independent of the flyweight's context, so it's shareable. And then extrinsic state, so it depends on and varies with the flyweight's context, so it's not shareable. So that means that the client objects are responsible for passing extrinsic state to the flyweight when it needs it. So for my motivation for flyweight pattern, most document editor implementations have text formatting and editing facilities that are modularized to some extent. However, they usually stop short of using an object for each character in the document, even though doing so would promote flexibility at the finest levels in the application. So what could be done, you could uniform characters in embedded elements with respect to how they are drawn and formatted. And then you can extend the application to support new character sets without disturbing other functionality, and then mimic the document's physical structure. So this image here shows how a document editor can use objects to represent characters. Problem with that, main problem, is the cost. Even moderate-sized documents may require hundreds of thousands of character objects, which will consume a lot of memory and may incur unacceptable runtime overhead. So the flyweight pattern that we will talk about describes how to share objects to allow their use at finding granularities without prohibitive cost. So for the example, a document editor can create a flyweight for each letter of the alphabet. Each flyweight stores a character code, so the coordinate position in the document and its typographic style can be determined from the text layout algorithms, and then the formatting commands in effect wherever the character appears. So logically, there's an object for every occurrence of a given character in the document, which is the image on the left. But physically, there is one shared flyweight object per character, and it appears in different contexts in the document structure. So each occurrence of a particular character object refers to the same instance in the shared pool of flyweight objects, which is shown in the image on the right. Here is the class structure. For example, a glyph is abstract class for graphical objects. So operations that depend on extrinsic state have it passed to them as a parameter. For example, draw and intersects must know which context the glyph is in before they can do their job. And a flyweight representing the letter A only stores the corresponding character code, so it doesn't store its location or font. The client then supplies the context-dependent information that the flyweight needs to draw itself. For example, a row glyph knows where its children should draw themselves so that they are tiled horizontally. And because of the number of different character objects is far less than the number of characters in the document, the total number of objects is substantially less than what a naive implementation would use. So an object abstraction thus becomes practical for individual characters. So you should apply the flyweight pattern when all of the following are true. An application uses a large number of objects. The storage costs are high because of the sheer quantity of objects. Most object state can be made extrinsic. Many groups of objects may be replaced by relatively few shared objects once extrinsic state is removed. And the application doesn't depend on object identity. So here is the structure for flyweight. If we just look at first flyweight here, it declares an interface through which flyweights can receive and act on extrinsic state. And then the concrete flyweight is for the character. It implements the flyweight interface and adds storage for intrinsic state. And then the unshared concrete flyweight, which is for rows and columns. Not all of them, the subclasses need to be shared It's common for the unshared concrete flyweight objects to have concrete flyweight objects as children at some level in the flyweight object structure. And then we have flyweight factory, which creates and manages flyweight objects as well as ensures that flyweights are shared properly. And then, of course, we have client, which maintains a reference to flyweights and computes or stores the extrinsic state of flyweights. Consequences of the flyweight pattern is that it may introduce runtime costs associated with transferring, finding, and or computing extrinsic state, especially if it was formerly stored as intrinsic state. And then, however, such costs are offset by space savings, which increase as more flyweights are shared. So storage savings are a function of several factors. We have the reduction in the total number of instances that come from sharing, the amount of intrinsic state per object, and whether extrinsic state is computed or stored. Some known uses. So the concept of flyweight was first described and explored as a design technique in Interviews 3.0. Developers built a powerful document editor called Doc as a proof, which uses glyph objects to represent each character in the document. The editor builds one glyph instance for each character in a particular style, and then documents are represented by a class called document, which also acts as a flyweight factory. Measurements in Doc have shown that sharing flyweight characters is quite effective, as in a typical case, a document containing 180,000 characters required allocation of only 480 character objects. And then also ET++ uses flyweights to support the look and feel independence. And those are my references. Okay, so here is the code. We have our base class glyph here. Glyphs are composites that have graphical attributes and can draw themselves. But for here, we are just going to focus on the font attribute. But the same approach can be used for any other graphical attributes a glyph that might have. And then we have the character class, subclass, which just stores a character code. And then the glyph context class is created to keep from allocating space for a font attribute in every glyph. So it acts as a repository of extrinsic state. And then the glyph factory acts as the flyweight factory, so it creates glyphs and ensures that they're shared properly. Glyph factory instantiates character and other kinds of glyphs. And then this one here, the character array contains pointers to character glyphs indexed by character code. And then create character looks up a character in the character glyph in the array, and it returns the corresponding glyph if it exists. If it doesn't, then it creates the glyph, puts in the array, and returns it. And then we have row and column, which basically just instantiate a new object each time they're called, since non-character glyphs won't be shared. So that is it. That's the end of my presentation on flyweight. I hope you enjoyed, and thanks for watching.